Hello and welcome once again to the Aakash byjus YouTube channel. My name is Atiullah and we are live yet again with another live session, this time on JEE Mission 2022. So if your mission is to crack JEE 2022, this is the right place to be. So before we proceed, just let me know if I'm audible properly and you can see me just right. Okay, give me a yes, give me a thumbs up and tell me if you can see me and hear me properly so that we can start with the session. Alright, how are you guys doing? JEE 2022. Okay, how many of you are appearing for JEE 2022 and how many of you are going to appear the next year? Do we also have people from class 11th or they're just people from class 12th? Just let me know. Alright, so I see a few thumbs ups and hi Harita, good evening, how are you doing? Good evening Aniket. Hi Shubhajit, hi Falak, how are you guys? Alright, so yeah, mostly I think people would be from class 12 because this is a class 12 topic, geometrical optics that we're going to deal with today. Alright, so I see the thumbs up, so let's start with this session. Okay, so we are here on our mission to JEE 2022. So what is the mini mission today? Our mini mission today is to discuss previous year and important questions from geometrical optics or ray optics. Okay, the idea is to understand, or the idea is to revise concept through questions. I would have given you a lecture. I could have told you, okay, these are the concepts, this is the formula, this is how you should study, all those things I could have said. But what I'm doing is I'm going to discuss questions, okay? And there's a good reason behind that. Now tell me something. Whenever someone has given you a riddle to solve, okay? Maybe you solved the riddle, maybe you did not, and someone gave you the answer ultimately, doesn't matter. But if someone has again asked you the same riddle, have you ever faltered? Has it happened that once you know the answer to a riddle and once again you have been asked the riddle, you're not able to answer that riddle, okay, or solve that riddle? Has that happened, ever happened? That does not happen. But if someone gives you a list of things to remember, like my mom used to give me a list of things to go and buy from the market. She'll tell me, you buy eggs, you buy bread, you buy dhania, of course, because why was boys born? To buy dhania. So she would give me a list of 10 things and she would ask me to write it down, but I would never write it down because I was smart and I said, why should I write it down? I would remember all those 10 things. But I would go to the market, I'll get 8 things and for sure I'm going to forget 2 things. Okay, this is what happens to you also. Okay, there are 10 things you need to remember, 8 or 6 or 5 things you are going to remember, but the rest of the things you are going to forget. Why? Because you consume that information as it is. You did not try to process that information. And unless you struggle with what you are learning, it is not going to stick. Okay, so if you are struggling with something that you are learning, then certainly you are going to remember that much better, because when you were solving that riddle, you struggled with the problem. And when you struggle with the problem, the solution or the answer to the riddle still sticks with you. That is why you never falter when you are asked again. Okay, this is how our brain works. So I'm not making this up. This is scientific, this is psychology, this is how our brain works. You can look this up. It is called effortful retrieval. So when we are trying to revise something, always start with a question. Okay, always start with a question, and then when you struggle with that question and then you try to effortfully retrieve it from your memory, then that revision is going to be very, very effective. All right, so with that said, we are going to discuss today important questions and previous year questions from geometrical optics. Okay, the other thing, this is not a movie, this is not a lecture, this is not stand-up comedy. So you can't just take a tub of popcorn and sit down and relax and watch. You cannot do that. So please take out your notebooks, please take out your pen, and we are going to solve the questions together. Okay, we have to deal with the questions together, and then only you are going to get any benefit out of this. Okay, so if you're ready, let's start this session. Let's get cracking with this session. All right, let's start. So are you ready for the first question? I'm going to start. We are going to solve it together. here we go with the first question. All right, what is it? Okay, let the xy plane be the boundary between two transparent media. Okay, so xy plane, what do we see here? Here is the x-axis. The y-axis is going to be into the plane of the screen. The y-axis is going to go something like this, into the plane of the screen. So if you take a plane which is perpendicular to the plane of the screen, that is the boundary. Okay, and then when we have z greater than equal to 0, which means we are talking about this region over here, the refractive index of the medium is √2. And when z is less than 0, which means we are talking about this region, the refractive index is √3. Okay, then we have a ray of light which is traveling from medium 1 to medium 2, and the ray of light, the incident ray of light, it has a vector, it is represented by a vector 6√3 I cap plus 6√3 j cap minus 10 k cap, and it is incident on the plane of separation. What do we have to calculate? We have to calculate the angle of refraction in medium 2. Okay, so this is medium 2, this is the angle of refraction, theta 2. So our objective is to find this angle of refraction, theta 2. Okay, tell me, what is the concept? What is the concept that we are going to use here? So whenever we are solving a question, the first thing I'm going to ask you is, what is the concept that we are going to use here? If you are able to tell me the concept, then only we are going to proceed. So what is it that we are going to use here? That's the important thing. To identify, whenever a question is thrown at you, instead of jumping at it randomly, the objective should be to identify that what concept is going to be applied over here. So can you tell me what is the concept that we are going to apply over here? Quickly. Snell's law. Falak says Snell's law, and you are absolutely right. We're talking about refraction at plane boundary. It's not a curved boundary, it's a plane boundary. So Snell's law is going to be, and sorry, for curved boundary also, Snell's law is absolutely applicable, no doubt about that. But since we're dealing with a plane boundary, then we are directly going to use Snell's law. Okay, Swastika is saying we'll consider only x and z coordinates of the light ray to find the angle of refraction. Not really. So what we need to understand from Snell's law is that it has two laws. Snell's law is basically sin I by sin r is equal to mu2 by mu1. That is something we know. And the refracted ray, the incident ray, and the normal are in the same plane. That I guess that's where you are coming from. Okay, but if we deal with vectors directly, if we know how to deal with vectors directly, then we don't need to worry about the coordinates. Okay, and I'm going to show you how. Okay, first thing first, Snell's law. What is Snell's law? Snell's law tells me that if this is refractive index mu1 and this contains the incident light, and this is medium of refractive index mu2 and this contains the refracted light, then mu1 into sine theta 1 should be equal to mu2 into sine theta 2. Is that correct? Haritha is saying, sir, the video is not clear. Okay, is that right? Aryan, yes Aryan, I am live. You can ask me questions if you have. Hi Piyush, good evening. Is it that the video is not clear? If you can tell me if something is wrong. I think it's clear. Most of the people are finding it absolutely fine. So Arita, you can just refresh it and try watching it again. Okay, cool, perfect. So we have Snell's law over here. Mu1 sine theta 1 is equal to mu2 sine theta 2. Is that correct? What are the things that we know? We know what is mu1, we know what is mu2. Okay, what do we have to find out? We have to find out theta 2. So what is it that we need to find out? We need to find out theta 1. Is that correct? So if we find out theta 1, then our job is done. Is that correct? How do we find theta 1? Okay, so this angle here is theta 1. Now how do I calculate this angle? I know what is vector A, and the angle it is making with the normal is something that we need to find out, correct? Now if I extend this, okay, if I extend this, so whenever I have to find the angle between two vectors, I have to join them either tail to tail or head to head. Now let's say I extend this vector A over here, and this is tail to tail, and this is, let's say, k cap. Okay, now this is the angle between vector A and k cap. Is that something I need? No, that is not something I need. I need this angle, okay? I need this angle over here. So what I can do is, I can say that this angle is between vector A and minus k cap, okay? Minus k cap I'm going to draw like this. Now A and minus k cap are head to head, and then this angle theta 1 is going to be the angle between vector A and minus k cap. Is that correct? So all we need to do is find out this angle. And how do we do that? How do you do that for vectors? Very simple. We can get the dot product. So what I'm going to do is I'm going to take the dot product of A and minus k, and this is going to be equal to A, okay, the magnitude of A, then the magnitude of k is simply going to be 1, and then what do we have? We have cos theta 1. Is that correct? The angle between vector A and minus k cap. Correct. Now if I do a dot product of this vector with minus k, what am I going to get? I'll only be left with this component. Is that correct? There's no I component, there's no j component. So if I take a dot product, I'm simply going to get 10. Is that correct? Are you with me? Perfect. So this is going to be equal to the magnitude of A. How do I find the magnitude of A? The magnitude of A is going to be 6 root 3 square plus 8 root 3 square plus 10 square and the under root of that. Is that correct? And then cos theta 1. Now let's quickly calculate this. So this becomes 10 is equal to, now we can use a shortcut, okay? We can use a simple calculation trick over here. Now we can take root 3 square common, and then we can write it as 6 square plus 8 square, okay? And then we have 10 square and the under root of that, and then we have cos theta 1. Is that correct? Okay, so this becomes 10 is equal to, now 6 square plus 8 square, what is that going to be? It's a Pythagoras triplet, 6, 8, 10, it's a Pythagoras triplet. So this is going to become 3, and then we'll have 10 square plus 10 square into cos theta, correct? So now if we take 10 square common, then we'll have 3 plus 1, which is 4. So we take the under root, that is going to become 10 times 2 into cos theta. Okay, this is cos theta 1. So this 10 and this 10 gone, which means cos theta 1 is equal to half. Is that correct? Cos theta 1 here is going to be equal to half. What is theta 1 going to be equal to? Theta 1 is going to be 60 degree. Is that correct? Alright, perfect. So what we have done is we have calculated theta 1. Now all we have to do is put it in Snell's law. Okay, mu 1. What is mu 1? Mu 1 is this. So this becomes root 2 into sine theta 1. And what is sine theta 1? Sine theta 1 is sine 60 degrees. So that is going to be equal to root 3 upon 2. And this should be equal to mu 2. What is mu 2? Mu 2 is root 3. And this should be equal to how much? This should, and here we have to multiply by sine theta 2 as well. Okay. So simply I have done is mu 1 sine theta 1 is equal to mu 2 sine theta 2. Correct. So this and this gone, this root 2 will make this root 2. So sine theta 2 is equal to 1 by root 2. So theta 2 is equal to 45 degree. Is that correct? Okay. So what should be our answer? Our answer should be 45 degree. Is that clear? What is the concept we have used? We have used the simple concept of Snell's law. That is it. Everything else was simple mathematics. Are you with me? Is that right? All right. Perfect. So what should be the correct option? The correct option should be 45 degree. Okay. Just a simple question to warm you up. We are proceeding towards more important questions. All right. Remember, what is the concept we revised? It was Snell's law. So what I'm going to do is that at the end of every question, I'm going to tell you what is the concept that we revised so that you can make a note of it, and this is going to be a concept checklist. Now go back and see if you know all these concepts or not. This is going to serve as a concept checklist. Okay, it is not going to be exhaustive because we cannot deal with everything, but it certainly is going to be the most important concepts. Is that correct? All right, perfect. Let's look at the next question. You are ready? Let's start. So we have a beaker which contains water up to a height h1, and then on top of that we have kerosene of height h2. All right, so the total height of the liquids becomes h1 plus h2. The refractive index of water is mu1 and that of kerosene is mu2. The apparent shift in the position of the bottom of the beaker when viewed from above is, okay, the situation is very, very simple. So we have water, which has refractive index mu1. On top of that, we have kerosene oil, refractive index mu2. And then we are watching from top, and obviously nothing is given. So this is certainly air. Okay. An object is placed at the bottom of the tank. We have to tell what is the shift. Okay. First things first, what is the concept? Can you quickly tell me what is the concept involved in this question? Are you able to dig the concept? Let me know quickly. I am waiting. Okay, unless I get the right answer, I'm not going to proceed. Okay, what is the concept we are discussing over here? Can you tell me? Real and apparent depth. Priya, very close. Yes, certainly. We are talking about real and apparent depth. And just a step after real and apparent depth, we understand or we study what is the apparent shift. Is that correct? Yes, Piyush is also right. So apparent shift, okay, apparent shift is given by the thickness of the medium into 1 minus 1 upon mu relative. Is that correct? Okay. Now the question is, what is mu relative? Or some people just remember it as mu. Okay. Some people just remember it as mu. But that is a problem. That is a problem. If you just remember it as mu, it means that this is the refractive index with respect to air. You are watching from air. Okay. You are observing it from air. The medium is air. Okay. So if tomorrow instead of air I change it to some other thing, then you will be struggling finding the answer. Okay, so that is why I write it as mu relative. Now what is mu relative? This is the refractive index of the slab. Okay, whatever is causing the shift, it is the refractive index of slab with respect to the medium. Okay, this is the generalized result we should remember, because tomorrow if we change the medium in which we are observing, the medium from which we are observing, then we'll have trouble. Okay, so that's it. Okay, so delta x is given by this. This is a well-known result. We know that very well. But the major concept here is, okay, so let's say the object is placed over here. Then the light ray will go like this. Then it will go like this. Then it will go like this. And then the image is going to be formed here. Okay, so this is the apparent shift. Is that correct? Okay, so this is how the shift looks like. Perfect. But tell me one thing. If we calculate the shift over here, then what we do is, this is the slab. This is the slab right here. The object is over here. Okay. Now let's say we calculate the apparent shift and then we move the slab. Okay. We move the slab by a little bit. Is the apparent shift going to change? Okay, we move the slab a little bit towards the downward direction. Does the apparent shift change? Does the apparent shift that we calculated is going to change? Can you tell me yes or no? Okay, we are keeping the object as it is. We are moving the slab. We move the slab up. We move the slab down. Tell me if the apparent shift is going to change or not. Quickly, let me know. Falak says yes. So Falak, you are saying that apparent shift is going to change. Apparent shift is going to change if we change the distance between the slab and the object. Is that what you're saying? All right. Bubby is asking, will do NEET classes too, sir? Okay, so basically these are concepts that we are studying. This is going to apply to JEE. This is going to apply to NEET. Okay, so we are interested here in concepts. So whatever exam you are preparing, this is going to help you, but we are focused more towards JEE. Okay, okay, Falak, it might. No, look at the apparent shift. So apparent shift is t into 1 minus 1 upon mu relative. Where is the object distance? Where is the object distance in this formula? Nowhere. Okay. So whatever be the distance between the object and the slab, the apparent shift is not going to change. The apparent depth and real depth are going to change, but the apparent shift is not going to change. Is that correct? Okay. So what I'm going to do is I'm going to do a little cheating over here. Okay, this is the situation given to me. Now this is the boundary between kerosene oil and water. But what I'm going to do is I'm going to do a little bit of cheating. I'll separate out these media. Okay, I'm going to separate out this media. This is height h1, this is height h2. Now in between, this is water, this is air. Okay, this was air over here. What I've done is I've just shifted the upper liquid a little bit. Okay, so then what we are doing is we are watching from here and we are watching from here. Is that correct? Okay, now in this case, what is going to happen? Why was I able to shift these slabs and it is not going to affect my answer? Because the apparent shift does not depend on the distance between the object and the slab. Is that correct? So what I'm simply going to do is, since I've separated them, I'm going to calculate the shift due to mu1, and then I'm going to calculate the shift due to mu2, and the net shift is going to be the sum of these two shifts. That is it. Alright, that is it. So the important concept here was that the apparent shift does not depend upon the distance between the object and the slab. Okay, now finding the answer is very simple. Writing down the answer is very simple. Okay, so what I'm going to do is, what is the shift due to mu1? It is going to be h1, which is the thickness of the medium, and then we have 1 minus 1 upon mu relative. But relative we are talking about with respect to the medium or the surrounding. Okay, what is that? That is air. So I don't need to worry about that. So this is simply going to become mu1. And then what is the shift due to the other liquid? It is going to be h2. It is going to be h2 into 1 minus 1 upon mu2. Is that correct? Simply I have calculated the shifts due to these individual media. Okay, and that is going to give me the net shift. Is that correct? Clear? Are we clear over here? So what was the concept we understood over here? The first very important concept we understood over here was that the apparent shift does not depend on the object distance. Is that correct? Alright, so what have we learned here? If we have composite slabs, if we have one slab of certain medium, other slab of certain medium, other slab of some other refractive index, we have mu1, mu2, mu3 and so on. No matter how many slabs we have, if we have to calculate the total shift, all we have to do is calculate the shift due to individual slabs, add them up. That is going to give you the right answer. Clear? Are we clear over here? Okay, so write down these two concepts that we just discussed. It should go in your concept checklist. Alright, so option C is going to be the right option. Are you ready for the next question? Let's go for the next question. Alright, so what do we have? We have a fish looking up through water and sees the outside world contained in a circular horizon. Okay, we'll discuss this. If the refractive index of water is 4/3 and the fish is 12 centimeter below the water surface, the radius of the circle r in centimeter is. Okay, I'll first explain the question. And then we're going to talk about the solution. Okay, now this is the fish. What they are saying is the fish is going to see the outside world in a circular horizon. Circular horizon meaning the field of view of the fish is going to be circular in nature. Okay, that's what they're saying. And if that is the case, we have to find out what is the radius of that circle. Okay, perfect. Now you tell me what is the concept that is involved over here. And since I have shown you the ray diagram also, you should be able to you should be in a position to tell me what the concept is going to be. Okay, so quickly can you tell me what is the concept involved in this question? How are we going to solve it? What is the concept that is involved over here? Which phenomena is involved over here? Any guesses? Any guesses? What is going on over here? Total internal reflection. Absolutely. Swastika says, TIR Piyush says total internal reflection. Yes, you are absolutely right. You are spot on. Okay, so let's understand this. Now, before talking about what the fish is going to see, it's easier to see how others are going to see the fish. Okay, think about it. So let's say light rays are going out of the fish. Okay, someone is outside trying to look at the fish, light ray is going outside. Okay, so if light ray is going like this, at this boundary, what is going to happen? The angle of incidence is going to be 0, so the light ray is going to go straight ahead. Then let's say light goes like this. Okay, light goes like this. We'll draw the normal. This is going to be the angle of incidence. Okay, at a certain position, light is going like this. So this is going to be the angle of incidence. So what do we see? As we are going towards the right or towards the left or towards the front or towards the back, in all directions, if we are moving out, basically the angle of incidence is increasing. And we are going from denser medium to rarer medium. Okay, so this is the denser medium because this is water and outside it is air. So we are going from denser medium to rarer medium. What does it mean? Well, it means that at a certain angle, the angle of refraction is going to become 90 degree. What is the angle called? That angle is called theta c. Okay, that angle is called the critical angle. Beyond this angle, what is going to happen? Beyond this angle, the light ray is going to get totally internally reflected. Hence, there is going to be no light ray outside beyond that point. Is that correct? Okay, so this is how the world is going to perceive the fish. Correct? Now, by principle of reversibility of path of light, okay, if I can see you, it means light from you is coming to me. But if I can't see you, which means that light from you is not reaching me, which also means that light from me is not going to reach you. So if you can't see me, I also can't see you. Is that correct? Okay. So this is how the world is perceiving the fish. So the fish is going to perceive the world in the same manner, which means if I erase all of this, fish will not be able to see beyond this region. Is that correct? Beyond this region, light from beyond this region will not be able to reach the fish, which means fish, the field of view of fish is limited to this cone. Is that correct? So on the surface, we'll have a circular ring which will make its horizon. Is that correct? Okay. So we have to find out what is the radius of this horizon that we see. Is this concept clear? Okay. Alright, so if this concept is clear, let's try to solve this. Okay, so let me draw this diagram. Okay, we have drawn this diagram. What does it mean? That this point, at this point, the angle of the angle of incidence is going to be grazing. Correct? So this angle over here is going to be the critical angle. Is that correct? So if light goes like this, it is going to go like this, which means this angle here that I have marked is going to be the critical angle. Is that correct? Yes? Okay, so if this is the critical angle, then by alternate angle property, this angle is also going to be the critical angle. Is that correct? Okay, simple geometry. Okay, this is parallel line, this is parallel line, and what do we call it? I think we call it transversal, right? So this is alternate angles. So this angle is also going to become theta c. Is that correct? Okay. So what we are talking about is we are talking about this triangle. So from this triangle, what can I say? From this triangle, I can say that tan theta c is going to be equal to r by h. Is that correct? This height here is h. So tan theta c is going to be r by h. So r is going to be h tan theta c. Do you agree? So we have been given h. All we need to find out is we need to find out what is tan theta c. That's how we'll get to r. Is that correct? So my question boils down to finding what is theta c. Correct? Perfect. So what is the critical angle? The critical angle is given, or I can write the sine of the critical angle is equal to what? This is equal to 1 upon mu. Okay, this is equal to 1 upon mu. Obviously, what is the thing hidden here? The thing hidden here is that light is going from a refractive index of light is going from a medium of refractive index mu to air. This is the thing hidden over here. If it is going from mu2 to mu1, then this is going to be mu1 upon mu2. Is that correct? Clear? But here what do we have? We have light going from refractive index of 4 by 3 to refractive index of 1. Is that correct? So can we directly substitute that? Okay, let's substitute that. So this is going to become 1 divided by 4 by 3. Correct? So sine theta c is simply going to become 3 by 4. Do you agree? So if sine theta is 3 by 4, what is tan theta c? Can we figure that out? Okay, we'll make the triangle for your convenience. We'll make the triangle. So this is theta c. Then sine theta c is 3 by 4, which means perpendicular is going to be 3. The hypotenuse is going to be 4, which means the base is going to be how much? It is going to be 16 minus 9 under root, which is root 7. So from here, can we say that theta c is going to be equal to the perpendicular, which is 3 divided by the base. So 3 upon root 7. Is that correct? Okay, so what is R? R is equal to H tan theta c. Now you substitute the value of H, which is 12 centimeter. You substitute the value of theta tan theta c, and then what you're going to get? You're going to get R is equal to 36 upon root 7 centimeter. Is that correct? I see a lot of people have got that answer right. Varshini has got that right. Jyoti has got that right. That is awesome. Alright, so as promised, at the end of this question, what is the concept involved? The concept involved is this: critical angle and total internal reflection. What is critical angle? Critical angle is the angle of incidence at which the light ray, the refracted light, is going to be grazing. The refracted light is going to be grazing. Okay? Beyond this critical angle, there will be total internal reflection. Correct? Okay, so that is going to be my answer. I hope you have noted down the concept in your concept checklist, and option B is going to be the right option. Alright, so I hope this is clear. So let's move quickly to the next question. Are you guys ready for the next question? Here we go. So we have a transparent solid cylinder, and it has a refractive index of 2 upon root 3. It is surrounded by air. Okay, a light ray is incident at the midpoint of one end, so it is incident over here. The incident angle theta for which light grazes along the wall of the rod is. Okay, so what is the situation? Now we have a cylinder. It has a refractive index of 2 upon root 3, some refractive index. Outside we have air. Here also we have air. Here also we have air. Okay. So light ray is going like this. It is incident at this point. So what will happen? Obviously, refraction is going to happen. When refraction is going to happen, it is going to reach this point. Now again, this is a boundary of the cylinder and air, which means refraction is again going to happen, and it is told, or it is informed, that the light ray from this point on grazes the surface. Is that correct? So we have to find out what will be this angle theta. Is that right? Okay, now as always, tell me what is the concept we are going to use. Quickly tell me the concept that has to be used over here. Can you let me know what is the concept? What is the core concept that we need to know to solve this question? Okay, Falak says lateral shift. Think about it, Falak. Think about it. The angle, the refracted ray, I'll give you a hint. The refracted ray grazes the surface. Okay, it grazes the surface, which means what is the angle of refraction? Correct. Total internal, Varshini is again correct. This is going to be total internal reflection, or we can say this is critical angle. Yes, beyond critical angle we get total internal reflection. So what we are dealing with here is critical angle, because this refracted light is grazing the surface. So the angle of refraction is how much? It is 90 degree. Is that correct? Perfect. Alright, so how do you solve this question? It's pretty straightforward. No worries at all. Okay, so this is the incident light. It is falling at this point. So this angle given to us is theta. Obviously there will be refraction. So if there will be refraction, let's say this is going to be the angle of refraction. Perfect. Now this light is incident at this point. So what we're going to do is we're going to draw the normal. When we have drawn the normal, this angle here is going to be the angle of incidence for this surface. Do you agree? And how much is that angle going to be? Now this angle is 90 degree. This angle is R, which means this angle is going to be 90 minus R. Pretty straightforward. Okay. So the angle of incidence on this boundary over here, the angle of incidence on this boundary becomes how much? It becomes 90 minus R. And from this diagram, it's pretty easy to see that this is the critical angle. Do you agree? This angle 90 minus R that we see over here, this is the critical angle, because at this angle, the angle of refraction becomes 90 degree. Can you see that? Cool. So the question becomes very, very straightforward. Okay. The question is simply that the critical angle is 90 minus R. And what do we know about critical angle? We know that sine of the critical angle, the sine of the critical angle is given by mu1 upon mu2. Is that correct? So what do we have here? We have mu1 as 1, and what do we have as mu2? It is 2 upon root 3. So from here, sine theta c is equal to root 3 by 2, which means how much is theta c? Theta c is 60 degree. Do you agree? Now if theta c is 60 degree, then from this relationship, what is R? R is going to be equal to 90 minus 60 degree, which is going to be 30 degree. Correct? So R comes out to be 30 degree. Is that correct? So we have calculated what is R. Is that clear? That is the first step. We have calculated what is R. But our job doesn't end there. We have to calculate theta. Can we calculate theta? Okay. Can we calculate theta? So what is basically happening? At this point, there is refraction. And this is refraction at plane surface, which means I can very well use what is, we can very well use Snell's law. Can we do that? Of course we can do that. So I can say that mu1, so I'm talking about this refraction over here, this refraction. So it is going from air to that medium. Okay. So mu1 is going to be 1. This is air. So mu1 is going to be 1. Then we'll have sine theta is equal to mu2. What is mu2? Mu2 is 2 upon root 3. And then we have sine r. And what is sine r? Sine r is 30 degree. So I've simply applied the Snell's law at this surface. So from here, what do we get? We get sine theta is equal to, now sine 30 degree is half. So I'll be left with 1 upon root 3. Correct? So sine theta is 1 upon root 3, which means theta is going to be equal to sine inverse of 1 upon root 3. Is that correct? Are we clear? Any confusion in this question? Let me know. I can address that. Alright, but what is the important thing? What is the concept involved here? The concept involved here is critical angle. In the previous question also we used critical angle. Critical angle is in fact a very critical topic for JEE. Okay, we have had a lot and many questions from critical angle, because critical angle and total internal reflection are really related concepts. So you can get questions which have a combination of these two concepts. Okay, so I hope this is clear. We are I hope this is clear and you have noted down in your concept checklist critical angle. Alright, perfect. Let's move forward. So option B is going to be my right option. Piyush says answer is option A. No, I'm sorry Piyush. Answer is going to be, I think, sine inverse 1 upon root 3. Just check. Probably you have messed up a calculation somewhere. Okay, just check. Alright, let's get on with the next question. What do we have? Now we have a hemispherical glass body of radius 10 centimeter and refractive index 1.5 and is silvered. Okay, so this part here is silvered. What does silvering means? It means that simply it is going to become a reflecting surface. Correct? Perfect. Now a small air bubble is at 6 centimeter. Here is the air bubble. Below the flat surface, inside it along the axis, the position of the image of the air bubble made by the mirror is seen. Okay, So what do we need to find out? Where is the air bubble? Okay, and we have to see from here. Okay, so there are going to be two light rays. Okay, there are going to be two light rays, one which is going directly from this object to the eye, and there's going to be another light ray which is going to get first reflected from the mirror, and then it is going to go to the eye. Is that correct? Clear? So we have to tell that from the flat surface. Okay, the options are given are from the flat surface. So from the flat surface, we have to find what will be the position of the image. Is that correct? All right. So in order to solve these questions, or before I proceed with that, first I'm going to ask you, what is the concept that is going to be applied over here? Quickly tell me the concept that we need to use to solve this question. Okay, it may happen that multiple concepts are involved. Sure, it may happen. So just try and let me know what is the concept, what is the core concept, what is the phenomena that we are talking about over here. All right, Swastika says concave mirror. Yes, you are absolutely right. There is going to be reflection from the concave mirror. Absolutely, I 100% agree. So we are going to use mirror formula. Varshini is absolutely right. Yes, we need to use the mirror formula as well. What else? There is one more thing that we are missing. Can you think about it? There is one critical piece of information that we are missing over here. Okay? Refraction, because glass is there. Yes, now it is a complete answer. Yes, I love that. Now it is the complete answer. Excellent, Swastika. So what is going to happen? So first light ray is going to go like this. It is going to get reflected. Okay. But the eye is over here. We are viewing from the top. If you are viewing from the top, the light ray is going to go through this boundary and then only it is going to reach our eye. Is that correct? Now if that is going to happen, then the refraction is also going to happen. So this image formation is a combination of two processes. One, reflection at the curved surface, and then refraction at the flat surface. So we'll have to take both of these things into account. And what else do we know? The reflection or refraction by the image formed by the reflection or refraction acts as the object for subsequent reflection or refraction. Is that correct? So my mode of operation is clear. Now I have a clear picture. What am I going to do? Okay, so the object is here. First, I'll use the mirror formula to find out where is the image. Okay, let's say the image is formed over here. I don't know right now. Okay, let's say the image is formed over here. And then I'm going to use this image as my object for the refraction at the flat surface. Okay, so this becomes my job right now. Clear? All right, so first, what is it that we need to do? We need to find out what is the image, where is the image formed after the first reflection. Okay, so let's do that. So obviously, what do we have to apply? We have to apply 1 by V plus 1 by U is equal to 1 by F, which is the mirror formula. Okay, quickly, we're going to talk about the sign convention. This direction I'm going to take as positive because this is the direction of incident light, and all distances are going to be measured from here. Is that correct? That is the center of the mirror. That is the pole. All distances have to be measured from the pole. Alright, so let's go. So 1 upon V, that's what we need to find out, is equal to 1 upon U. What is U? U is this distance. And this distance is going to be how much? It is going to be 4 centimeter. Okay, 10 centimeter minus 6 centimeter, 4 centimeter. Okay, but it is in this direction, so I'll have to substitute it as a negative. So I'll substitute minus 4. This is equal to 1 upon F. Okay. What will be the focal length of this silvered mirror? Okay, what will be the focal length? The focal length is going to be half of the radius of curvature. What is the radius of curvature? It is 10 centimeter. So what will be the focal length? The focal length is going to be 5 centimeter, but it is a concave mirror. So for concave mirror, the radius of curvature is in which direction? It is in the negative direction, which means I'll have to substitute minus 5 centimeter. Is that correct? Alright, so from here, what do we get? We get 1 by V is equal to 1 by 4 minus 1 upon 5. This is going to give me 1 upon 20, which means V I have found out, and that is 20 centimeter. Alright, V has 20 centimeter, but what is the point from which we are measuring V? It is this point over here. Don't get confused. It is not the point O. Alright, So what do we have here? From this point at 20 centimeter, remember we came out to be positive. We came out to be positive, which means the image is on the other side. Okay, which means the first image is formed over here. Now the light ray is going to go like this and get refracted at this surface. Okay, now when refraction is happening, what is the formula that I can use? Okay, this is refraction at plane surface. I can certainly use apparent depth and real depth. Okay, so apparent depth divided by real depth is equal to what? It is equal to mu2 upon mu1. Correct? Now what is mu2? Mu2 is this medium, air. This is mu2. Would you agree? Because light is going from glass or whatever it is, glass to air. So it is the incident light is in glass, which means this is mu1. The refracted light is in air, which is mu2. Is that correct? Okay. So d prime upon d is going to be equal to mu2 upon mu1. And what is mu2? Mu2 is 1. And what is mu1? Mu1 is 1.5. Correct? So from here we can calculate d prime. But what is d? What is the apparent depth? The depth is always measured from the boundary. Nowhere else. The depth is always measured from the boundary. Which means this entire distance is going to be how much? This entire distance is going to be 30 centimeter. Is that correct? So that is going to be the value of d. So d prime will become 30 centimeter divided by 1.5, and this is going to give me 20 centimeter. So what is d prime? D prime is 20 centimeter. And from where? This apparent depth is also going to be from the boundary. So from the boundary at 20 centimeter, this is going to be the final image. Is that correct? Are we clear over here? Let me know any confusion in this question. Yes. It will appear to be at pole. No, not really. Not really, Swastika. It will not appear to be at pole because the pole is 10 centimeter below the surface. The pole is 10 centimeter below the surface, but the final image is 20 centimeter below the surface. So it will not appear at pole, it will appear below the pole. Is that correct? Okay. So what goes in your concept checklist? Pole will also appear to be shifted. Yes, it may happen that pole will also appear to be shifted. Yeah, certainly it may happen. Okay, but what we see here is that the image of the pole, I don't think the image of the pole and image 2 are going to coincide. I don't think they are going to coincide. You can do the calculation, you can check, but I don't think they can coincide because their real depths are different. So I don't think they are going to coincide. Anyway. Alright, so what goes in your concept checklist? The first thing is apparent depth and real depth. Okay, d prime upon d is equal to mu2 upon mu1. What is the next thing that goes in your concept checklist? It is the mirror formula. Okay, and the third thing that goes in your checklist is the image formed by a reflection or refraction acts as an object for the next reflection and refraction. Correct? Are we clear? Has that gone in your concept checklist? If that's done, let's go to the next problem. Okay, before that, I'll just give you the option. Option B is going to be the correct option, and we proceed to the next question. Alright, let's talk about this question. A thin convex lens made from crown glass, mu is 3/2, has focal length f. When it is measured in two different liquids having refractive indices 4/3 and 5/3, it has the focal lengths f1 and f2 respectively. The correct relationship between the focal length is, okay? So what we need to do here, if we look at the options, what do we understand? We have to figure out a relationship between f1, f2 and f. Whether f1 is greater than f2, f1 is equal to f2, or f1 is greater than f. Basically all those permutations and combinations. Basically we have to figure out what is the relationship between f1, f2 and f. That's it. That's our job. Okay? Let's go. Okay. First thing, what is the concept that we are going to use over here? Quickly let me know. What are we dealing with here? Which concept are we dealing with over here? We're talking about the focal length of lenses, right? What are we talking about? Which concept are we talking about? Which concept is involved here? Refraction. That's a very safe answer. That's a very safe answer. Of course it is refraction. Yes, this is under the umbrella of refraction for sure, but we have to be a little more specific. Okay, focal length if lens is in a medium. That's again a very smart answer. I would say that's a very clever answer, because yes, that is the situation we are dealing with. But I want to know what is the expression, what is the formula, or what is the concept that we need to use over here. Yes, Swastika has got that right. Lens formula. No, I'm so sorry. Not lens formula. It's similar, it's related, but it's not lens formula. It's something else. There's a difference between lens formula and lens something formula. Lens maker's formula. Yes, absolutely, Piyush. Yes, we are dealing with lens maker's formula. Is that correct? Okay. How does the lens form? And it was written right over here. The hint was right up here. I did not notice that. I shouldn't have put that up, but probably nobody picked up. Okay. Yes, we are using the lens maker's formula. What is the lens maker's formula? Tell me. 1 by f is equal to mu minus 1 into 1 upon r1 minus 1 upon r2. Okay, this is how we write the lens maker's formula, and this is a very stupid way of writing the lens maker's formula, because the information is hidden over here. Okay, the information is hidden over here. What is this mu? What is this mu? This mu is assumed that you are in air. The surrounding medium is air. This formula assumes that. It is not written very well in this formula. Okay, so we should use the lens maker's formula, but we should remember the generalized lens maker's formula. What is the generalized lens maker's formula? It is mu relative minus 1 into 1 upon r1 minus 1 upon r2. Okay, what is mu relative? Yes, absolutely, relative refractive index. What is this? This is refractive index of material of the lens with respect to the medium. Okay, we should write it like this. Okay, if we write it like this, then there is no confusion, because they have played with you over here. Now if you start using mu minus 1, you'll be confused. Which mu we have to use? Okay, if we directly use this mu, alright, so where is the mu? If we directly use this mu, we are going to get a wrong answer. So the focal length of the lens does depend on the medium. That is a very interesting fact, and something which is very important to remember. Correct? But now we know what is the generalized lens maker's formula, so we can do the substitution and figure out the relationships. Okay, first of all, 1 upon f, the focal length. When nothing is said, they are saying the focal length is something. It means that they are talking about the medium as air. Is that correct? Okay, so let's do that. So this is going to be mu. What is mu? Mu is 3 by 2 minus 1 into 1 upon r1 minus 1 upon r2. So this is for air. They're saying the focal length is this much. When no medium is specified, it means that they're talking about air as the surrounding medium. Is that correct? So I have written it for the surrounding medium. What I have not shown is that it should actually be 3 by 2, which is the refractive index of the lens, divided by 1. This should be the correct way of expressing it. Correct? Okay, so this is going to give me 1 by f is going to be how much? This is going to be half into, now this 1 upon r1 minus 1 upon r2, I'm going to call it k. Okay, I'm going to call it k, because we'll see that it's going to be a constant throughout our question. So what do we get? We get f is equal to 2 upon k. Correct? So the focal length in air is going to be equal to 2 upon k. Is that correct? Alright, so let's do that for other media also. So we are talking about this medium. Okay, the refractive index of the medium is 4 upon 3. So I'm going to substitute 1 upon f1 is equal to mu of the material, mu of the lens, divided by mu of the medium minus 1, and then I'll have 1 by r1 minus 1 upon r2. That is not going to change because the radius of curvature of the lens is not going to change, so this is still going to be k. So this will become 1 upon f1 is equal to 1 upon 8 into k. Have I done the calculation right? Just call me out if I have not done the calculation right, because I do tend to mess up calculations. Okay, this is going to give me 8 upon k. So f1 comes out to be how much? f1 comes out to be 8 upon k, correct? Okay, so let's quickly find out f2 also. So 1 by f2 is going to be the refractive index of the lens divided by refractive index of the medium. What is that? This is 5 by 3. So 5 by 3 minus 1, and then 1 upon r1 minus 1 upon r2, correct? So 1 by f2 comes out to be how much? It comes out to be 9 minus 10, which is 1, so minus 1 upon 10 into k. So f2 is going to be minus 10 upon k. ठीक है? और f पहले निकाल लिया था हमने. So we figured out what is f. F was how much? F was 2 upon k. Now let's look at the options. अच्छा ठीक है. We have already figured that out. Okay. So what will be the correct answer? F1 will be greater than f. F1 is 8 by k and f is 2 by k. So obviously f1 is greater than f, and f2 becomes negative. Is that correct? F2 becomes negative. So that should be my correct relationships between these three: focal lengths. And what should be my correct option? Option B should be my correct option. Is that correct? Okay, the most important thing at the end of this question, what should go in your concept checklist? Quickly tell me. I need to know from you. What should go in your concept checklist? You need to tell me what are you going to note down in your notebook right now. Yes, what goes in your concept checklist? Lens maker's formula. Samarth, you are 67% right. Lens maker's formula. All of you are only 67% right. Where is the remaining 33%? So yes, absolutely right. This is lens maker's formula. But what I told you is, remember the generalized lens maker's formula. ठीक है? Mu minus 1 into 1 by r1 minus 1 by r2 is good but not good enough. Okay, so we should remember it as 1 upon f into mu relative minus 1 into 1 upon r1 minus 1 upon r2. What is mu relative? Refractive index of the lens with respect to the medium. And there is one more thing hidden in this formula. Which I should specify. ठीक है? So let's say this is mu 2. Let's say this is mu 1. Let's say this is mu 1. Then you can apply this formula. Very good. Perfect. But let's say this is mu 3. Then again you cannot apply this formula. Are we clear? So when we are using the lens maker's formula or the generalized lens maker's formula, we should remember that the medium on both sides of the lens should be the same. Okay. And there was a question in JEE Advanced, I think, where they had changed the medium on the other side. Okay, so you will fall in this trap. So do remember this as well. All right, this goes in your concept checklist, and then we move forward. All right, what do we have next? We have a car. It is fitted with a convex side view mirror of focal length 20 centimeter. A second car 2.8 meter behind the first car is overtaking the first car at a relative speed of 15 meter per second. The speed of the image of the second car as seen in the mirror of the first car is. Okay. Question is pretty straightforward. One car is going. There is a convex mirror. Swastika is asking, so what to apply in that case? Okay, I think you're talking about a case when this becomes mu 3. This is what you're asking, right? In this case, yes, in this case, I'm sorry, there is no ready-made formula. Okay, if I derive a formula also, it is going to be too complicated, but solving that is not difficult. Okay, all that is happening is there are two boundaries. So this is going to become one boundary for refraction. That is going to be the refraction between mu1 and mu2. You find the image that is going to act as an object for the next boundary. This is going to be a boundary for mu2 and mu3. So all we'll have to do is we'll have to take two refractions and solve it. Okay, it's not going to be very difficult. All we have to do is take two refractions and solve the question. Okay, but the careful thing that the thing we need to be careful about is not to misuse the lens maker's formula. Yeah, all right. Okay, so here we are talking about a car. It has a convex or side view mirror, and the speed of the second car is 15 meters per second with respect to the first car. So we need to find out what is the speed of the image. Is that correct? Okay, what concept are we talking about over here? Quickly let me know. What is the concept we are talking about? And if you tell me what is the concept we are talking about, also tell me the expression or the formula that we can use. Tell me that as well. Wow. Mu u3 by v minus mu1. All right. Varshini is saying mu3 by v minus mu1 by u is equal to mu2 minus mu1 upon r1 plus. I'm sorry, Varshini, I don't know about this formula. Okay. Maybe it might be the right result, but I never remember this as a formula. Okay, if you have a situation where mu1, mu2, mu3 all are different, then the best way is to go with two refractions, because remembering too many formula, that is not going to happen. Okay, if you remember too many formula, most likely you'll mess it up in the exam. Okay, obviously we need to remember results, but remembering everything, making everything a formula, it's not really going to help. Alright, movement of image. Yes, we are talking about velocity of image. Okay, so there will be some velocity of the object, consequently there will be some velocity of the image. Can someone tell me about the expression that I should use over here? Yes, I need to find out what is the velocity of image. Can you tell me what is the expression that I should use for velocity of image? Velocity of image is equal to minus v square upon u square into velocity of object. Absolutely, spot on, Varshini. Yes, absolutely right. Excellent. Okay, ever wondered how do we get that? This is the mirror formula. What do? We differentiate on both sides with respect to t. So here what do we get? We get minus 1 upon v square dv by dt, and then we get minus u square and then du by dt, and this is equal to 0. And from here we get, so what is dv by dt? dv by dt is not acceleration. Okay, v is the image distance. So dv by dt is the velocity of the image. So velocity of the image, that comes out to be minus v by u ka square, and then du by dt is the velocity of object. Okay, or we write velocity of image is equal to minus m square into velocity of object. What is m? M is the magnification. But this is absolutely right, but there is something hidden in this formula. All of this has to be with respect to the mirror. Okay, if the velocities are not given with respect to the mirror is also moving, other things are also moving. So the first thing you'll have to do is you'll have to find all the velocity. You'll have to find the velocity of the object with respect to the mirror. Okay, thankfully in this question, velocity of object with respect to the mirror is already given. Okay, so this is already given, so we don't need to worry about it. But in this formula or expression or whatever you call it, it is hidden that this has to be with respect to the velocities, have to be with respect to the mirror. Is that correct? Once we know this, solving this question is a piece of cake. No problem at all. Okay, so velocity of image with respect to mirror we have to find out. This is equal to minus m square velocity of object with respect to mirror. So all I have to do is find out what is the magnification. Very simple. I know the focal length. Where is the focal length? The focal length is 20 centimeter. Okay, I know the object distance, it is 2.8 meter from the mirror. So how difficult is it to find out the magnification? Not at all. So I'm going to directly use f upon f minus u. Okay, don't tell me you're going to first find v, then you're going to do minus v by u. Don't do that. Okay, save a step. So magnification for the mirror, I'm going to directly use it as f upon f minus u. F is 20 centimeter. I'm going to write it as 0.2 meter because this I have in meter. Okay, so we have 0.2 meter divided by 0.2 minus, sign convention is again going to be of importance. This direction I'm taking as positive because that will be the direction of incident light, which means u will come out to be how much? It is going to be negative. So I have to substitute minus 2.8. Is that correct? So this is going to give me 0.2 divided by how much? Divided by 3. That is going to be the magnification. Correct? I found out the magnification. Let's put this into the equation. So this becomes minus 0.2 by 3 ka square into velocity of object with respect to mirror. How much is that? That is 15 meter per second. Alright, so this is going to become how much? This is going to become minus 0.04 upon 9 into 15. So 3 times, 3 5 times. This is going to give me minus 0.2 upon 3, which probably I can multiply and divide by 5. So I'm going to get minus 1 upon 15 meter per second. Alright, so the velocity of the image with respect to the mirror is going to be minus 1 upon 15 meter per second. Minus meaning that the relative velocities are going to be in the opposite direction. Okay, so if you just have to tell the speed, then the speed is going to be 1 upon 15 meter per second. Is that correct? Okay. Now this was this was velocity of image when the object is moving longitudinally. Okay, if the object is moving along this principal axis longitudinally, okay, then this is valid. Can someone tell me if the object is moving laterally? Let's say the object is moving laterally or perpendicular to the principal axis, then what is the velocity of image in that case? Can someone tell me? Okay, if you're revising one concept, then we should also touch upon a related concept, shouldn't we? Quickly, can someone tell me, in that case, when the velocity of the object is perpendicular to the principal axis, or we call that the lateral direction, in that case, what will be the velocity of image? Then the image will not move along the principal axis. Yes, but the image is certainly going to move perpendicular to the principal axis, isn't it? In that case also we'll have some velocity of the image. Okay, that's why I showed you the derivation pehle. That's why I showed you the derivation. Any answers for my question? Yes, Varshini is absolutely right. In that case, it becomes velocity of the image with respect to the mirror is equal to m times velocity of object with respect to the mirror. In that case, we don't have minus m square, we simply have m. Okay, so this is also something we should remember. This should go in your concept checklist as well. Clear? Are we clear with this question? Okay, so I've given you the result as well as I've given you the derivation as well. Okay, so things may change. Do remember the derivation because there could be some twists and turns in the questions. Okay, you can expect that. Alright, let's move to the next question. From here, option D is going to be my right option. And let's move to the next question. Okay, so we have a plano convex lens of refractive index 1.5 and the radius of curvature 30 centimeter. And it is silver. The curved surface is silvered. Okay, so we have a lens. The curved surface is silvered. Now this lens has to be used to form the image of an object. At what distance from this lens an object be placed in order to have a real image of the size of the object? Okay. Words are a little confusing, but what they simply mean is that this curved surface of the lens is silvered. Where should you place an object so that a real image is formed, and real image is formed of the same size of the object? Okay. Clear? What is the concept involved? Quickly tell me what is the concept involved. what is the concept involved over here? How do we deal with this question? Can someone throw some light on that? It has to be placed at the center of curvature. You're right, Swastika. If it has to be a real image and it has to be of the same size, it has to be placed at the center of curvature. But my question is, the center of curvature of what? So a lens, does that have a, so basically does a lens have a center of curvature? It's a lens, right? One part is silvered, but the lens doesn't have a center of curvature. Lens has two curvatures, and each curvature is going to have a different center of curvature. Of the mirror. Alright, Varshini says effective F must be found. And Swastika says of the mirror. So if I combine both of your answers, then that answer is absolutely right. So what we can do is, when we silver a lens, okay, when we silver a lens, then it starts acting as a mirror. Okay? Since this is the surface we have silvered. Which surface? So this surface we have silvered, so it will start acting as a concave mirror. Okay, so there are two ways to solve this question. One is a good old-fashioned way of solving this question, which is something like this. And I'll encourage you to know both the methods because they have different benefits. Alright, the object is placed over here. Now one thing is for sure, that if it has to be a real object and the image and the size of the object and the size of the image has to be the same, it basically means that the object and image has to coincide. Is that correct? Alright, the object and mirror, the object and the image has to coincide, only then this situation is going to be fulfilled. Okay, now this, when we have silvered this, it is going to be a combination of one refracting surface over here. Now this is no more a lens, okay? This is no more a lens because a lens has two refracting surfaces. Now this is a combination of one refracting surface, one refracting surface, and this becomes a mirror. And this is a reflecting surface. So this becomes a combination of one refracting surface and one reflecting surface. Is that correct? Now in this case, if the image has to be coinciding with the object, then we know how that is going to happen. That can only happen if the light ray retraces its path. And how does the light ray retrace its path? It only retraces its path if at the final object, the final reflection, it is at normal incidence. Is that correct? So if I have to draw the ray diagram, then there will be a ray of light like this. This is going to refract and then it is going to fall perpendicularly on this mirror. If it falls perpendicularly on this mirror, it is going to retrace its path and the image is going to be formed over here. So for the mirror, it will appear that the light ray, for a mirror, it will appear that the light ray is coming from the center of curvature. Is that correct? Okay. So what we can do is we can find out. So what do we need to find out over here? We need to find out what should be this distance. Okay. Is that correct? This is what we are after. We need to find out this distance. Okay. First of all, what is the radius of curvature? The radius of curvature is 30 centimeter, which means this distance over here is 30 centimeter. Do you agree? And I'm taking distance from the flat surface of the curved surface. It's the same thing because it's a thin lens. Okay, I'm assuming it is a thin lens. So the distance, the thickness of the lens does not matter. Okay, so this is 30 centimeter. Which means that the object for the concave mirror is placed at a distance of 30 centimeter. Do you agree? For concave mirror, it should appear that the light is coming from the center of curvature, which means for the concave mirror, the object is going to be at 30 centimeter, correct? Which means this is going to be the image for the first refraction, okay? So the first refraction, the image formed after first refraction, let me write that I1. the image formed by the first refraction I1 is going to act as the object for the mirror, correct? So basically we have placed an object at a distance u and the image is formed over here. The image is formed at this distance. Do you agree? And why that has happened? Because of refraction at a plane surface. Okay, so here what we can directly use is, we can directly use the apparent depth and the apparent depth relationship. So we are going to say that d prime upon d is equal to how much? It is going to be equal to mu2 upon mu1. Correct? So what is d prime? What is d prime? What is d prime? The image distance from this surface. What is d prime? D prime is 30 centimeter. What is the object distance? U. That's what we need to find out. What is mu2? Light is going from air to the glass. So what is mu2? Mu2 is glass. And what is mu1? Mu1 is air. So U comes out to be how much? It is 30 upon 1.5, which is going to be equal to 20 centimeter. Is that correct? Okay? So this is one way of solving this question. Okay? The other way is to take it as a combination of a concave mirror and plano-convex lens. Okay, so what we can do is, we can use this expression 1 upon f of the mirror. Now this combination is going to act as a mirror. Okay, this combination is going to act as a mirror, and the equivalent focal length of this mirror will be given by 1 upon fm is equal to 1 upon focal length of mirror minus 2 upon focal length of lens. Okay, so you simply find out what is the focal length of this plano-convex lens, and then you find out what is the focal length of this concave mirror. Then you use this relationship, you will find out what is fm. If you find fm, then the answer is going to be twice of fm, the radius of curvature, correct? That is another way of solving this question. So I leave up to you which method you find better, which method is more helpful for you. Clear? Okay, so what goes in your concept checklist? In your concept checklist goes silvering of lens. Okay, when we are silvering lens, when we are silvering a thin lens, then yes, this expression can be used. And the other thing is that when image coincides with the object, it means that the last reflection happened at normal incidence. Okay, these two things should go right now in your concept checklist. And let's look at the options. So option A is going to be the correct option. And then let's move forward. Okay, let's quickly move forward. We have a few questions to deal with. Let's quickly move forward. All right, let's go. We have a convex lens of focal length 20 centimeter and a concave mirror having a common principal axis are kept 80 centimeter apart. Okay, the diagram shows that very easily. Now, when an object is kept at 30 centimeter to the left of the convex lens, matlab the object is placed over here, its image remains the same position even if concave mirror is removed. Okay, this is very interesting. When concave mirror is there, the image is somewhere. When you remove the concave mirror, the image is still there. Okay, that will have a interesting consequence. Then the maximum distance of the object for which concave mirror by itself will produce a virtual image. Okay, virtual image is produced by a concave mirror when it is within the pole and the focus. Is that correct? Okay. So what we have to do is, if we find out what is the focal length of the concave mirror, then my answer will be the focal length of the concave mirror. Do you agree? Okay. The maximum distance till the focal length, if I'm keeping it, I'll get a virtual image. Beyond that, I'll start getting a real image. Okay. Does it mean that the image is not reaching the concave mirror? No. Swastika is asking me, does it mean that the image is not reaching the concave mirror? It cannot happen because this is refraction. When light is going from here, it has to pass through. Okay, from where does it pass through? I don't know, but it has to pass through. It is a lens, it is not a mirror. Light is not going to go back. Light has to cross over. ठीक है, तो concave mirror पे incidence तो होगा. It is going to strike the concave mirror. It is going to get incident on the concave mirror. Alright, so what is going to happen? Let's think about that. Now the first thing is very simple. We have the focal length of the lens and we have the object distance. We can certainly find what is the image distance. Can we do that? We can certainly find what is the image distance. Okay. Now let's say concave mirror is not there. Okay, let's say concave mirror is not there. Then image is formed over here. Do you agree? Now let's say now concave mirror is here. then the image should be formed at the same place, which means the image again is being formed at this place. Is this clear? Is this logic clear? Take a, let me say that again. Suppose right now there is no concave mirror. Where is the image? The image is here. Now we put the concave mirror. The image does not go anywhere. The image is still there, which means after reflection also the image is still there. What does it mean? It means that the images coincide. Yes, this is going to be normally incident on the concave mirror and it is going to go back like that. The light is going to retrace its path. Is that correct? ठीक है? तो सबसे पहले what should we do? We should find out what is the image distance. Okay, so I'm going to use 1 by v minus 1 by u is equal to 1 by f. 1 by v we have to find out. U, obviously this direction I'm going to take as the positive direction as per my sign convention. Then u is going to become minus 30. This is equal to 1 upon f. What is the focal length? It is 20 centimeter. So 1 by v is going to be equal to 1 upon 20 minus 1 upon 30. This is going to give me how much? LCM is going to be 60. So क्या मिलेगा मुझे? मुझे मिलेगा 1 upon 60. यानी कि v आ गया. V has come out to be 60 centimeter. मतलब this distance is how much? This is 60 centimeter. Correct? Now think from the perspective of the mirror. Now think from the perspective of the mirror, the light ray is basically normally incident. If it is normally incident, then what does it mean? It will appear the light is coming from the center of curvature of the mirror. And if that is the center of curvature, then this is going to be the radius of curvature. Do you agree? Which means what is the radius of curvature of the mirror? Radius of curvature of the mirror is going to be 80 centimeter minus 60 centimeter, which is 20 centimeter. Matlab, what will be the focal length? The focal length is going to be 10 centimeter. I'm dropping the minus sign because uska bhi meko kaam nahi hai. Okay, the focal length is going to be 10 centimeter. So where should you place the object in front of the concave mirror to get a virtual image? So from pole till focus. Beyond that, you can't get a virtual image. So what should be my answer? My answer should be 10 centimeter. Is that correct? What goes in your concept checklist? Again, it's the same thing. It's the same concept we discussed in the last question. Okay? When image and object is coinciding, light is getting retraced, means the incidence on the last mirror is normal. Perfect. So option B is going to be my right option. Let's quickly do a few more questions. Alright, let's quickly do it. These are simple questions. Now we have a prism. So monochromatic light is incident at a certain angle on an equilateral triangle prism. Equilateral triangle matlab 60, 60, 60. Correct? Ye bhi 60, ye bhi 60, ye bhi 60. And it is given that it suffers minimum deviation. If the refractive index of the prism is √3, the angle of incidence is. Okay, it is given to us that this is minimum deviation. Now can someone tell me what happens in minimum deviation? Obviously you know what is the concept we are talking about. We are talking about minimum deviation in the case of a prism. Now what happens during minimum deviation? You tell me. You look at this diagram over here and you quickly tell me what happens when minimum deviation occurs. What happens when minimum deviation occurs? I is equal to E. Jyoti says I is equal to E. You are spot on, Jyoti. I is equal to E. Yes. Angle of incidence and angle of emergence become equal. And then what happens? And then what happens? Swastika is saying the refracted ray is parallel to the base. I have some issues there. The refracted ray is parallel to the base. I know that's something you have quoted from a standard textbook. It's written everywhere, but I have a problem with that and I'm going to explain to you. Okay. The other thing that happens is that these angles become equal. Do you agree? These angles become equal because sin I by sin r is going to be equal to mu2 by mu1. And the same thing we are going to apply at this boundary also. So if I and E are equal, then R1 and R2 are also going to be equal. Okay? And what we know is that R is equal to A by 2. Do we know this relationship? ये relationship पता है ना? ठीक है? तो generally क्या होता है? A क्या होता है? A is R1 plus R2. True? A is R1 plus R2, which means if R1 and R2 are the same, then this becomes A is equal to 2r, r is equal to A by 2. A is given to me as 60 degree, so R will become 30 degree, correct? So from there what will happen? You can apply Snell's law over here. So this will be mu1 into sine I is equal to mu2, which is root 3 into sine R1. Do you agree? So this is going to be equal to sine I is equal to root 3 into sine R1. Sine 30 degree is going to be half. So this becomes root 3 by 2, which means angle of incidence will come out to be 60 degree. Correct? Okay. So the thing I was talking about. What is the consequence of minimum deviation? I is equal to E. Yes. R1 is equal to R2. Yes. Now suppose we do not change the diagram, but my base was like this. I do not change the diagram. I do nothing with the diagram. Okay. I just change the base. I make the base a little slanted. Is that going to affect my ray diagram in any way? Can that affect my ray diagram? Nah, it cannot affect my ray diagram. Okay, so the statement that this ray becomes parallel to the base is only going to be valid when you have the base angles equal. Okay, when base angles are equal, then it is going to be parallel. So it is a consequence of minimum deviation, but it happens because I becomes E, R1 becomes R2, and the base angles are equal. Okay, so that is why I don't remember that. It need not be parallel. But what is sure to happen is I is equal to E, R1 is equal to R2. That is sure to happen. Okay, that's something we need to keep in mind. Okay, so I comes out to be 60 degree, and option D is going to be the correct option. And I hope you have put this down. What happens in minimum deviation? You have put this down in your concept checklist. All right, next question. What do we have? A light ray is incident perpendicular to one face of a prism, of a 90-degree prism, and is totally internally reflected at the glass air interface. If the angle of reflection is 45 degree, we conclude that the refractive index N is. Okay, so Astika is saying then it is not be parallel, so it holds good for equilateral triangle. Yes, it will hold good for triangles with equal base areas. It will hold good for that situation. Okay, but if base angles are different, it will not hold. Okay, perfect. What is this question? So there is light ray coming over here, normal incidence. Okay, so it will go like this. I'm sorry, the angle of incidence is 0 degree, so it will go like this. Here it gets totally internally reflected and then comes out like this, correct? So we have to comment what will be the range of the refractive index. Okay, so what concept are we talking about? Obviously, we are talking about total internal reflection at this surface. Okay, so one thing is for sure, total internal reflection is happening. What is the angle of incidence? Angle of incidence is 45 degree, which means 45 degree is greater than theta c. Can I say that? 45 degrees the angle of incidence and total internal reflection is happening, which means 45 degree is going to be greater than the critical angle. Do you agree? So sine being what is sine? Sine is a increasing function in the first quadrant, which means sine 45 degree is going to be greater than sine theta c. Do you agree? Which means sine 45 degree is 1 upon root 2 greater than sine theta c. Sine theta c is equal to what? It is mu1 upon mu2. Okay, so this medium is going to be mu1, this medium is going to be mu2, correct? Okay, so sine theta c is going to be equal to mu2 upon mu1. I'm sorry, it is going to be equal to mu2 upon mu1. So sine theta c is going to be equal to mu2 upon mu1. What is mu2? Mu2 is air, so this becomes 1 divided by mu1, which we need to find out. So this becomes mu1 greater than root 2. Do you agree? Okay, so we cannot tell the exact value of the refractive index, but we can certainly say that it will certainly be greater than root 2. Is that correct? So what should be my answer? My answer should be n, or mu should be greater than root 2. What should be the correct option? The correct option should be n greater than root 2. Option B should be the correct option. Alright, so this was it for this session. What are the takeaways from here? You are going to look at all the concept checklists. You'll see, are you comfortable in these concepts or not? And wherever you find that, no, this is something I've forgotten, this is something I'm not very confident in, pick those specific topics, go back, solve a few questions, revise your notes, and then you'll be good to go. All right? So that is it. I hope you are able to extract the full, you are able to extract all the benefits from this session. So I'm going to see you very soon in another session like this. Till then, keep practicing, keep getting better, and have fun with learning. See you very soon.